going to be talking about the second law of thermodynamics today. All right. So first of all, the second law states that the entropy of an isolated system never decreases. It will either increase, remain the same, and it is irreversible. It also states that unless there is some work done, thermal energy never flows from a body at colder temperature to a body at hotter temperature. And then lastly, the conversion of thermal energy to work is never perfectly efficient. So those are the three things that the second law of thermodynamics states. I'm going to talk about each one of them individually. First of all is entropy. At least when I took thermodynamics, everybody used to talk about entropy, and I honestly never knew what it was, so I feel like it's very important to highlight what this is. Entropy is a measure of randomness or disorder of a system. The more disorder or chaotic a system is, the higher the entropy. And then, for example, a gas spreading throughout a room has higher entropy than the same gas confined to a corner, because the gas throughout the room has more possible positions and velocities. And to further explain that, here is a diagram of that. As you can see, the gas particles are more spread out, so there's more opportunities for them to be in different positions compared to the solid. All the particles are next to each other, so there's less randomness in the system. All right, second is the flow of heat. In nature, heat always flows from a hot object to a cold object without any internal or external influence. In order to reverse the natural flow of heat, you need to add work into a system. And then, for example, the refrigerators. Refrigerators convert electricity into work, and this reverses the natural flow of the heat. And then the last thing is the heat engines part. Heat engines are devices that convert heat into mechanical work. The second law sets limits on the efficiency of heat engines, which convert heat energy to work. And it states that no heat engine can be 100% efficient, as some energy will always be lost to entropy, typically as waste heat due to the surroundings. So as you can see in the diagram, you have a hot reservoir, and your Q is your heat added into the system, and then it produces work, and this reservoir is the energy lost to heat. All right, and Carnot efficiency is the theoretical maximum efficiency of the heat engine. Carnot efficiency assumes that there is no thermal energy lost in heat. Since the second law of thermodynamics states that this is not possible, we know Carnot cycles are not possible. And basically, Carnot cycles are just used to see how close to ideal a design heat engine is. So it's used as a comparison. And here are a couple of equations that help define the second law of thermodynamics. We have your change in entropy is equal to the negative heat added into a system over your temperature. And like I said earlier, this is always greater than or equal to 0. We have your heat engine efficiency. This is equal to the work output of your heat engine over your heat added of the system. And then we also have the Carnot cycle efficiency, which is equal to 1 minus your low temperature divided by your high temperature. And we have that your heat engine efficiency is always less than or equal to your efficiency of the Carnot cycle. Any questions?
So here is my question. You have a question?
I have a question.
Sure.
Okay. What, if anything, did you learn while putting this presentation together?
Definitely about entropy. I had always remembered Dr. D talk about entropy, but I feel like he never really explained what it was, and just to be able to understand that it's just randomness of particles and stuff. That's definitely one thing that I learned.
Nice.
You have some question?
Oh no.
Yeah, what I wanted to ask, looking at the universe, do you think the entropy of the universe is increasing or decreasing or is remaining constant? The universe as a whole. What do you think? I don't have the answer to this question.
I think it would be increasing because as the universe expands, there's more space and more randomness to happen. So if you increase the volume of the universe, the entropy would increase because there's more randomness and
does that mean at some point, like, the entropy will get so high that maybe the universe will explode or something?
I
Because
thought
if it's
that was
increasing,
like a
like,
known fact.
what do you
I
say?
said I thought that was like a known fact, that
Really?
entropy is always increasing.
I think it's a theory, right?
Oh,
I don't
it
know
might
if
be a
it's
theory, I
proven.
guess.
No, I think
Yeah,
it would.
yeah, it's enough that it's always increasing, but if it's increasing, what do you think will happen if it keeps increasing? Like,
Scientifically, we will be gone.
okay.
We will be gone one day.
Yeah, it comes to, yeah, that's all. Thank you.
Thank you.